Hello, in this video we are going to go over the solution of the problem 1143, longest common subsequence. We are going to solve this problem using dynamic programming bottom-up approach, and let's consider this example where I have text 1 as A, B, C, D, E and text 2 as A, C, E, and I'm going to develop the DP matrix for that. And as we go forward, we try to develop the formula for our bottom-up approach. Okay, let's break down the problem to subproblems. We could say my text 1, instead of A, B, C, D, E, let's say that is just E, and my text 2 is also only E. So now I can fill out this cell. So what is the common substring if I have text 1 as E and text 2 as E? That is 1. So I put 1 here. Okay, we could say maybe we could develop the root number 1, and we could say if my text 1 R equals my text 2 C, I can say dp of R and C equals 1. So I'm just saying if this is matching to this one, so we know we can put 1 here. Okay, so for the rows we used index R, for columns used index C. So that could be our rule 1 so far. Okay, let's go forward. Okay, now let's consider the other cell. Let's consider this cell. When I'm considering this cell, I'm technically comparing letter E. So my first text has only one letter, and that is E. So my second text is this one. Now I'm matching E to CE. So what is the common subsequence? We know that is 1, because E doesn't match C, but it matches E. So E doesn't match C. So I could say that is 0 because they don't match. And then I look at from the right side and say, okay, there is a 1 letter that matched that. So I put that 1 here. So I can return 1. Okay, it seems that my second rule, rule number 2, is that if text 1R is not equal to text 2C, so what I'm doing is that I say dprc equals 0 plus, from the right side, from the dpr c plus 1. Okay, that is my rule number 2 so far. Okay, let's continue with the other cell, this cell. Again, I'm comparing E to ACE. So according to the second rule, I put 0 plus, that it comes from the right side. I already know the common substring between E and C is 1. So I use that from the right side. So I put it here. So it's gonna be 1 here. So far this formula works for this cell as well. Now let's consider this cell. So when I'm considering this cell, I'm comparing E to DE. D doesn't match E. I put 0 plus. In my second rule, I'm gonna modify second rule and add plus dp r plus 1 c. I can also consider the dp from the down. So from the down, I consider that. So that is gonna be 1. So I'm gonna put 1 here. Okay, let's continue for another one. So for example, between E and CDE, again, C doesn't match E. 0 plus 1 coming from here. So it's gonna be 1. Now between E and BCDE, again, B doesn't match E. It's 0 plus 1 coming from down. So it's gonna be 1. Now matching E between ABCDE. Again, E doesn't match A. 0 plus 1 comes from down. So it's gonna be 1 here. So our formula so far is correct. Okay, now let's consider this cell here. We are comparing DE with CE. Okay, C doesn't match D, so we put 0 plus. Now I have two options. I can come and consider this cell. So for this cell, if I consider that from the right side, it means that I'm considering an option that E is matching to DE. One solution that we should look. The other one that comes from the down, from here. So in that case, I'm considering the CE to E. For any of them, for this specific cell, I have one as the solution. From the right side, I have one. From down, I have one. But in general, I have two possibilities. So I can consider this one or this one. So which one should we select? We should select the one that gives us the maximum, because at the end, we are going to return the longest substring. So we should modify our rule number 2. We could say dp of rc equals 0. We don't care about that. So we put the maximum of dp of r c plus 1 and dp of r plus 1 c. Okay, now this is gonna be our second rule. Okay, now I use this formula. From the right side is 1, from down is 1, maximum between 1 and 1 is 1, plus 0 it's 1, so it's gonna be 1 in this cell. Okay, let me clean this rule number 2 a little. Okay, now let's consider this cell here. Okay, for this cell I'm comparing CDE to CE. And C matches C. It means that we are at rule number 1. We are going to develop that further. So right now we know that C matches C, so at least I have 1. But what should I consider from the cells around it? So you can see that C matches C. So in that case, I only need to compare E to DE. We have done that. So that is basically this cell. So I just need to put the value from that cell and sum to 1. So here is 1 plus 1, so this should be 2. So I modify my rule number 1 and say that dp r c equals 1 plus dp r plus 1 c plus 1. This is the diagonal. Again, when they match, it means that the c and c are matching, and we just need to compare the rest of that. Here we compare the e to de, which is this diagonal element that we already calculated that. Okay, so this is our modified rule number 1. Okay, let's clean this and continue. Okay, let's continue using these two rules to fill out the other cells. For example, for this one, D doesn't match A, we are at rule number 2. So we know that we should compare the maximum from the right and down. So I put 1 here. The other cell is this one. So for this one, we are comparing CDE to ACE. For this one, C doesn't match A. Again, I'm at rule number 2. So I consider the maximum from down and right. So maximum of 2 and 1 is 2. So this one should be 2. Let's consider this cell. For this cell, I'm comparing BCDE to CE. B doesn't match C. Again, I'm at rule number 2. So I consider the maximum from down and right. So this should be 2. Let's continue with this cell. We are comparing this one to ACE. B doesn't match A. Rule number 2. Max from right, from down, it's 2. Now let's consider this cell. For this cell, we are comparing A, B, C, D, E to CE. A doesn't match C. Rule number 2. Max from down and right. So this one is also 2. Okay, now we are at the last cell. So for this cell, we are comparing A, B, C, D, E to ACE. And you can see that we are comparing the whole elements of text 1 and text 2. So technically this is our output. So for this one, A matches A, so we are at rule number 1. So which means that A matches A. So technically we need to provide the answer 1 plus the result of matching of this substring to this one. So that which is already calculated at this diagonal location. So we just provide that from here. So 1 plus 2. So the final answer for us is 3. And 3 is dp 0, 0 that we are gonna return as our output. So to calculate the last row and last column of dp in our code, so it's more convenient to pad this matrix with zeros. And you can see that doesn't change anything in our rules, because for example, when we compared E to E for this cell, we got 1. So here we got 1. So dp r plus 1, c plus 1 is 0. So 1 plus 0 equals 1. So that is correct. Or you can check it for another cell that uses rule 2. For example, this cell where A doesn't match E. So we are at rule number 2. And from down we got 1. From right side we got 0. So the maximum between 0 and 1 is 1. So that is correct again. So it's totally fine to pad zeros to calculate our dp matrix. Okay, let's start writing the code. Okay, we are going to have a function that gets two inputs, text1 and text2. And you could say the r and c are the lengths of text1 and lengths of text2. Okay, now I'm going to initialize our dp, and so we say that dp equals 0 for I in range of c plus 1. We want to have one extra column for 0 padding, and this array for j in range of r plus 1. So at the end we are going to return the dp 0, 0, return dp 0, 0, which is the top left corner when we are comparing the whole text1 to text2. Okay, now let's fill out the dp cells using the two rules that we created. So we could say for r in range of r minus 1 to minus 1 in reverse order, and for c in range of c minus 1 to minus 1 in reverse order. So for rule number 1, we say that text1r equals text2c. Then we say dp of rc equals 1 plus dp of the diagonal element. Okay, so we say if text1r equals text2c, dp of r c equals 1 plus dp of r plus 1 c plus 1. Else, when they don't match, we say dp r c equals, so second rule is saying the maximum of dpr c plus 1 dpr plus 1 c, maximum of dpr c plus 1 dp of r plus 1 and c. Okay, let's run it, and we can see the answer is 3, and that's the value we expect for this example. Okay, now let's talk about time and space complexities. Our time complexity is order of n, where n is the length of text1 plus 1 times length of text2 plus 1. So we can just ignore these ones. So we could say that is the length of text1 times the length of text2, or we could say that is r times c. Okay, Our space complexity is also order of n because we created this dp and we need n spots to record the values. Okay, this is the solution of the problem 1143, and thank you so much again for watching this video.